This is problem number 7 of our calculus optimization problem set. A manufacturer has been selling 1,000 television sets a week at $450 each. A market survey indicates that for each $10 rebate offered to the buyer, the number of sets sold will increase by 100 per week. If the weekly cost of producing X television sets is C of X equal to 68,000 plus 5X, how should the manufacturer set the size of the rebate in order to maximize its profit? First, some issues about the problem. I have been using this for a couple of years now. I think it's possible to sit down and Filipinize the problem. For example, write this in terms of pesos rather than US dollars. It's just that right now my priority is to ensure that the numbers I use are easy with regards to calculation. So I've kept the figures as they are. I could have simply changed 450 to pesos, but now on the other hand, that would be too distractingly ridiculous. The second thing, this isn't just a single store to be able to sell 1,000 television sets. So let's assume it's a factory or it's a big retailer to be able to process such a big quantity. Now, profit is by definition revenue minus cost. Cost is what it takes to get the items on the shelves of your grocery. So that's 68,000 plus 5x. So that's at the start what you spent. So it's money out of your pocket. Revenue, on the other hand, is the amount that comes into your pocket, and it's based on the actual purchases. So for example, if you're able to sell 1,000 television sets at $450 each, then the revenue would be the product. It's 1,000 times 450. I just said the product. And then the profit would be the difference, in particular revenue minus cost. Now, so the situation is that we're looking at selling the TV sets not necessarily at 450, but we are looking into decreasing the amount by $10. For the purposes of this problem, you can think of a rebate as a discount, and it's supposed to be proportional. So, for example, the problem mentioned reducing the price by $10 and the number of TV sets should increase by 100. All right, so I should have like slid this up the slider 450 and then 1000, and then if you reduce the unit price by 10, then the number of TV sets sold goes up by 100. But we also mean to interpret this as meaning if you're going to reduce the unit price by just 5 instead of 10, where 5 is half of 10, then the number of TV sets sold should increase by half of 100, which is 50. All right. So just so the pattern is clearer, if you reduce the unit price by twice 10, then the number of TV sets should go up by twice 100. You know, supply, demand. Am I referring to? No, it's not law. It's not supply and demand. It's, well, the lower the prices become, then I suppose the greater the demand for that should be, which is just reasonable. So in this problem, the clear indication of movement lies in the number of jumps you make in the unit price, where each jump is a step down of $10, and correspondingly, each jump in the number of TV sets sold would be, well, of size 100, 100 TV sets. So to give a mathematical to assign a mathematical variable to this problem, most of us might choose x to represent the number of jumps. So in particular, if the unit price is represented by 450 minus 10x, so x is the number of jumps of size 10 from the original unit price, then the number of TV sets sold should be 1000 plus 100x. However, you have to be careful with the variables you assign, because if you represent these figures this way, then you're saying that x represents the number of jumps in this table. However, x has already been reserved for something, the number of television sets. So in this case, because x already means something else, there are others to choose from. Let's choose some other variable other than x. So let's use n. N is the number of jumps being described in the problem. But our cost function is in terms of x. So we should express the profit and the revenue also in terms of x. Now, how do we do that? We try to find a link between the number of television sets x and n, the number of jumps here. Well, what is x? Is the number of television sets. And isn't this expression the mouse is circling? That's the number of television sets. So therefore, x is 1000 plus 100n. And because we want to express everything in terms of x instead of n, then we should take this equation and solve for n. So that's a straightforward algebra. And it's x minus 1000 over 100. And substitute that into 415 minus 10n. So this n here is what's going to be replaced. 415 minus, what should I read? I mean, you can see it there. Which means that in terms of x, which is the number of television sets, then the corresponding unit price would be, after algebraic simplification, 515 minus 1/10 of x. And therefore, the revenue, what customers pay you, would simply be the number of TV sets that were sold multiplied by the price of each. So the revenue is this product. And so therefore the profit function being the difference of revenue minus cost is something that we could easily write down later. But just like other maximization, minimization problems, we have to identify the domain. So the number of TV sets sold x should be non-negative, greater or equal to 0. And of course the unit price should also not go lower than 0. So if you take the second inequality, you get an upper bound for the value of x. So the domain is 0 up to 5500, and as promised, the profit is revenue minus cost. You merely take the difference of the revenue we determined and the cost that was provided, and voila. What you have here is this function. And as for the critical numbers, we of course have to look at the first derivative, and this is a polynomial, it's never undefined, so we just need to ask ourselves when this is 0. Straightforward algebra tells us that x has to be 2725. And because the domain is a closed interval, we only need to evaluate the profit function, this negative 1/10 x squared expression, at the endpoints 0 and 5500, and at our sole critical number 2725, determine which of the outputs is the largest, which is clearly obvious. It's the second one. So 674,562.50, that is the largest possible profit. But don't forget, answer the question. If the question was what's the maximum possible profit, then it would have to be this amount. But the question is, what should the size of the rebate be? The rebate was the overall discount, and if you go to the unit price table here, all right, the rebate is it's not the number of jumps we went down, but the actual amount that the unit price was decreased. So therefore, the rebate is 10 times n, or in terms of x, 10 times x minus 1000 over 100. And because to maximize the profit, x should be 227.25. Plugging it into this expression gives us 172.5. So to maximize profit, the rebate should be 172.50. So the unit price should be $450 minus this rebate. End of problem. However, before I finally let this go, some of you might be wondering whether the actual steps that we did here are all necessary. For example, do we really have to identify the domain, because isn't the profit function a quadratic function? So wasn't it just merely an issue of determining the vertex, its y coordinate, because we're trying to find the largest possible value of P. Its graph is a parabola which opens downwards. So don't we just have to look at the y-coordinate of the vertex? To a certain degree, yes. But however, consider the following modification of the problem. The domain was 0 all the way to 5500. Suppose we had the following constraint. In addition, suppose that the company can only manage or sell at most 2,500 sets, which means that the domain 0 to 5,500, that's not really the working domain here because, well, we earlier were open to the possibility that X could be 5,500, the number of TV sets sold, but the company can only manage or sell up to this particular cap, 2,500. What that means is that the domain would have to be modified into 0 to 2,500. So what's the difference now? Compare the critical number, 2725. It's not in the domain anymore, which means that in the end, when we compare the function values, we're not even supposed to consider P evaluated at 2725. And of course, 5500 would change. So instead of doing three function evaluations, it would just be these two, all right, P of 0 and P of 2500. So because then the situation is going to change, well, we see that the profit is different as it was, but hey, it's a different context, and the corresponding rebate computed similarly will be a different amount, 150. All right. So, yay.